Good morning, everyone, and welcome to the Alternative Technology Association's webinar series for 2012. Our webinar today is entitled Energy Efficient Lighting and will be presented by John Knox. Firstly, just so people who may not know the ATA particularly well are aware of us, we're a 30-something-year-old not-for-profit organisation, and we specialise in providing information and advice to households, communities and others in regard to sustainable living. Energy efficiency, energy efficient lighting are an obvious and very important part of that sort of work. These webinars have been brought to you and supported by our good friends at bankmecu, who have been our partner in a wide range of energy efficiency and renewable energy projects over quite some time now. Our presenter today is John Knox. John is an ATA staff member. He started his working life as an electronics design draftsman back in the 1970s, and he's been an electronics research assistant and a systems administrator during his career. He joined the ATA as our web shop manager in 2008 while completing his Cert 4 in renewable energy at MIT in Epping, for which he was awarded an Excellence in Studies Prize. John's presented many talks on energy efficiency and technology for a sustainable future to a wide variety of audiences. He is exceptionally passionate about his topic. In July 2010, at the age of 54, John got on his bicycle to present talks to communities around Australia in an endeavour to get energy efficiency back on the agenda. If you're interested in that, www.ridethetalk.com.au will give you more information. After 22 weeks and over 8,500 kilometres of solo cycling, towing a trailer around the country, he returned to us at the ATA with a greatly expanded experience in talking to audiences, diverse audiences, and an even stronger passion for getting the message out about the need to use energy wisely. The icing on the cake, of course, is that by reducing energy use, you reduce your carbon footprint and your bills at the same time. Can I hand you over then, in a moment, to John Knox? Just before I do that, I should say in terms of the schedule for today's webinar, John's presentation will run for half an hour to 40 minutes, and then we'll have at least 15 minutes for questions and answers. It's very important to us that these webinars are interactive. There's not much point us just talking to a group of people and telling you what we think is important. We like to know from you what you think is important. So the Q&A part of these presentations is always very, very essential. To ask a question, let me just say for those of you who haven't been involved in one of our webinars before, the bottom right-hand corner of your screen, the messages box, is where you can ask questions. So if you start posing them as we go, I'll moderate the questions at the end and hopefully we'll get to everyone's, or to answer any question anyone's got. So thank you very much for joining us. I'll now hand over to my friend and colleague, John Knox.
Good morning, everyone. This is all very new to me, so at this point in proceedings, I would normally be asking my audience to turn off their mobile phones, and I'd also be giving them instructions in how to find the toilets if you were to need them. This, of course, is unnecessary at in this format. But feel free to come and go from the presentation as you desire. Well, we'll head straight in, but the first thing we need to talk about is energy. And what is energy? Energy is actually power over time. The unit for energy is the joule, and you also see the kilowatt hour. There is a relationship between the joule and the kilowatt hour. Gas is normally measured in megajoules because the joule is actually 1 watt second. It's a very small amount of power over a small amount of time. Electricity is normally measured in kilowatt hours, and 1 kilowatt hour is equivalent to 3.6 megajoules. Now, you've probably seen on your food packaging that the adult recommended daily intake of food is 8.7 megajoules. That's equivalent to about a quarter of a litre of petrol's embodied energy. Now that actually perhaps will make you think about fuel in a different way. The fuel that you take into your car. in a different way. Move on to the next slide. Lighting. Historically, the first form of lighting was artificial. Artificial lighting was from burning torches, hanging them on the wall. In fact, the reason we like warm white light is that we've been programmed to expect that form of light when we're indoors. Cool white light, which is light that is at around about the 5,500 to 6,000 degrees Kelvin, is much closer to natural daylight. Now, I'm about to bring up a slide on the color temperature chart, and this is a little bit counterintuitive. The higher color temperatures are in fact cooler temperatures, which just doesn't really make a whole lot of sense, but warm white is, and I'll point it out, warm white is down the bottom here, and cool white is up the top. You can see that sunlight, daylight, is around the 5,500 Kelvin. Candlelight is around 2,000 Kelvin. Your standard incandescent lamps are around about 2,700 to 3,000 Kelvin. And your fluorescent lamps come in a range of colors that vary from about the 2,500 up to about 6,500. Now, it's taking a little while to change between slides. I'm sorry about this. Now, lighting. Energy use in the domestic environment. Lighting has actually dropped in its, hang on, lighting, sorry, I'm trying to adjust this and it's going all over the place. Lighting, as you can see, is now taking around about 7% of our domestic energy use. This used to be between 12 and 15% back in the early noughties. That's reduced because we're tending to use a lot more compact fluorescent lamps. And normally I'd be asking my audience whether they're using compact fluorescent lamps, but I expect that as the majority of audiences that I've spoken with, you will probably be using compact fluorescent lamps at home. Now, if you're not using compact fluorescent lamps, and the reason you're not using compact fluorescent lamps is because of the mercury that is in the bulbs, and you've heard of the bad effects of mercury, then I would like to actually reassure you that by burning the extra coal in order to power the extra energy to light the bulbs, the incandescent bulbs, you'll actually be producing more mercury from the burning of the coal than is contained in the bulb. So if mercury is a problem for you, then dismiss that from your mind, because you're adding more mercury into the environment and other pollutants from the burning of the coal. Now, in the domestic environment, lighting takes up 7%, but in the commercial environment, lighting actually accounts for about 17%. And this is because lighting in the commercial sector is on for a whole lot longer during the day. And organizations make it such that the lighting has to be good lighting for you to be working by. Now, 17%, if the commercial sector can actually reduce that dramatically, then that actually takes a lot out of their lighting bills, their energy bills. By utilizing some new technologies in terms of managing the use of lighting, organizations like Google are now saving over 60% in their lighting costs, which is a great saving for them, but it also helps as far as their environmental credentials are concerned. Because as you know, organizations like Google use a lot of energy for other things. Next slide is coming. Okay. I haven't got it on my screen. Okay. Goodbye to incandescent lights. Okay. Okay. The transitions are not happening properly on this, unfortunately. I wasn't aware that the transitions would not be occurring. Okay. Disposal is an issue for the CFLs. They're good, but disposal is an issue, and a lot of councils now have recycling facilities for compact fluorescent lights. Compact fluorescent lights also don't tend to turn on immediately. They don't come up to full brightness, and they don't like turning on and off quickly. By turning them on and off a lot, you tend to reduce their lifetime quite considerably. The light can also be harsh. The type of light that you're wanting to look for, if you're finding the light from your compact fluorescent lights, is harsh, then look for warm white or around about 3000 Kelvin for your color temperature. And because of the turning on and off, you probably won't get, and the feedback I've had from people in my journey around Australia is that you don't get the full 8,000 hours that are stated on the packet. Now, LEDs, on the other hand, are much better. They have no mercury. They come to full brightness immediately. They come in a range of colors that range from warm white to cool white, and they last for around about 30,000 hours. They're expensive, but getting cheaper. And we now have in our web shop at the ATA for under $20 a 60-watt equivalent bulb. And I've got an example of it here, 60-watt equivalent bulb. It even looks like a pretty much a standard light bulb. And I'm going to turn it on. I'll just bring it up. Can I bring it up? There's the bulb. I'm going to leave that out to the side here. Turned on. It's a little bit of a waste of energy. That bulb is a 60-watt equivalent. It only uses 5 watts of 60-watt incandescent equivalent. It only uses 5 watts of power. Now, okay, this is a slide showing the luminous efficiency. As you can see here, this is your, that was supposed to be red. This is your tungsten incandescent bulb. And that, as a light source, it makes a great heater. Only 2.5% of a standard tungsten incandescent bulb is converted into light. The rest is heat. And in fact, a tungsten incandescent bulb, it actually creates its light by heating up the metal until it's brilliant. It's actually glowing hot. That's actually why the filaments in the bulbs actually fail on them, because the actual metal is actually vaporized and then recondenses onto the filament, vaporizes, then recondenses. Your quartz halogen light, and I'm having a bit of a problem with my cursor here. Quartz halogen is a little bit better, but it's still under 5%. your typical LED bulb these days, they're running at about 80 lumens per watt, and they're about 12% efficient. The current maximum that is available commercially is about 24% efficient, and that's 160 lumens per watt. But the theoretical maximum is about 300 lumens per watt, and that would make the amount of energy turned into light at just below 45%. So you can see that LEDs have the potential to dramatically change the amount of energy that we use to light our world today. Compact fluorescent lamps are a little bit less than 10%. They're 8 or 9%. So the current generation of LEDs are better than compact fluorescent lamps already, and will be more than twice as good as compact fluorescent lamps in the long term. Well, in the long term, they'll be probably about 4 or 5 times compact fluorescent lamps. And your standard T8 fluoro, which is your long, 3-foot long fluoro bulb, they're around about 15% efficient. So LEDs, your standard LEDs that are available today, they're at the 12%, and in the next couple of years, you'll see them up around the 23-24%. Now, these are the bulb bases that you see in general. They're Edison screw. The 27 refers to the diameter in millimeters of the bulb base. So that's a 27 millimeter diameter bulb base. Bayonet cap, which is bayonet 22 millimeters. GU10, that's again the distance between the 2 pins. There are 240 volt downlights, so they don't have the transformer in the ceiling. Small Edison screws, they're 14 millimeters in diameter. The small bayonets, they're 15 millimeters, and the MR16. They're also called a GU 5.3. So that 5.3 refers to the millimeters between the pins. Now, the MR16 is the downlight that has the transformer in the ceiling. Now, I'm going to be talking more about downlights, because downlights are kind of important. Downlights, and again, unfortunately, the slide transitions haven't shown. The problem with downlights, you may have heard during the course of the insulation debacle that occurred, that we had house fires. Well, those house fires occurred because the installers of the insulation actually placed the insulation over the top of the downlights. They were untrained installers, and so they didn't know any better. That was a bad thing because it caused house fires. As a light source, halogen downlights make great heaters, and the way in which you can tell that, if you were to put your hand up near the ceiling, near the lights, you don't even need to get all that close. You can actually feel the heat coming off that halogen downlight. Now, that's wasted heat. And in summer especially, that's wasted heat, because if you're cooling your house, your actual air conditioning has to work overtime in order to actually reduce the temperature because of your lighting. And that's something that is an added bonus by moving to LED downlights. Now, when I was growing up, we used to have a single 75 watt pearl bulb in the middle of the kitchen. These days, it's not unusual to see 10 downlights lighting that same area. Now, each of those downlights, and I'm going to disregard the transformer losses here, just for ease of calculation. Those 10 downlights took the place of a 75-watt bulb. Now, 10 by 50, because each of those downlights uses 50 watts of power, 10 by 50 is 500 watts. Now, 500 watts as opposed to 75 watts. We call that progress. I don't. That's a massive increase in use of energy in order to actually live our lives the way we used to. Now, that looks even worse if you consider that 75-watt pearl bulb could be replaced by a 15-watt compact fluorescent light. 15 versus 500, and that's not taking the losses into consideration. Now, that's just crazy. Also, those downlights, in order to avoid the fires, you actually have to pair the insulation away from those downlights. Now, that has another problem in that by pairing the insulation away from the downlights, you create heat chimneys for your winter heating to go straight up into the ceiling. Now, each of those spots, and if you've got 10 downlights in an area, each of those spots has got to have a clearance of 200 millimeters around each of those downlights. It's quite a substantial portion of your insulation is turned into Swiss cheese. Now, there are ways around that. If you replace your energy hungry halogen downlights with an energy miserly LED downlight, you can actually put a thing called a downmet, and there are other devices on the market, but these are a downmet, and I've got one here. It's a fairly substantial looking device. Looks a bit like a dunce's hat. I won't put it on because this is a serious presentation. You put those down over the top of the lights from inside the ceiling, and then you can repack your insulation around it, and that restores your insulation to some semblance of normality, thereby saving your heating costs and indeed your cooling costs in summer as well, because when your ceiling space gets pressurized by the air heating up in the ceiling, it'll actually push the air down into your living space. So this saves both summer and winter. Next slide. Okay. Mine seems to be taking a long time to switch, but that's okay. Lighting. Of course, the best way to save energy, turn off your lights if you're not using them. And that goes for even if you're using energy-saving lights, because you don't need to be funding the retirement of the energy generators. Save your money, fund your own retirement. Now, I've had this LED downlight on for quite some while now. A standard incandescent bulb, if you'd had it on for this sort of period of time, you wouldn't be able to touch it. It would be so hot, because incandescent lights as a light source make great heaters. This is a great bulb, and normally during my presentations I hand this bulb around the audience, and by the time it gets back to me, it's warmer than when it came away from me just by people handling it. That is how good LED downlights are as far as the heating. We're expecting a massive increase in electricity bills. We've already seen great, huge increases in electricity bills over the past number of years. The increases have been through network upgrades. That's the poles and wires. It's not really been because of increases in the cost of wholesale electricity, and it's not really been because of people putting solar panels on their roofs. There's been a slight increase with that, but it's mainly been attributable to network increases, and that's all to do with people putting great amounts of air conditioning on their homes. Now, we can expect these price increases to keep going up, by the way. These figures are 2005 to 2010s. We've also had the increase of just under 10%. That's to do with the price on carbon. The price on carbon is a good thing because it starts to move us away from traditional forms of generating electricity. Okay, I'm waiting for my slide to update. Okay, this is businesses. Businesses currently can have an instant asset write-off, and it's been that instant asset write-off has been upgraded from $5,000 to $6,500 for depreciable assets, and lighting is included in this. So you can instantly, if you're a small business and you're upgrading your lighting, then you can instantly write off that asset. More information is on the links below. I think this slideshow will be available for people to download afterwards. So if you're a small business, you can actually click on those links from within this presentation. These are some further resources that you can go to get information. Water and energy savings, sustainable living. The ATA is such a great resource. Go to the forums as well. The forums have a bounty of information that you can get. If you're interested in doing a greenhouse gas calculation on your own home, then the RMIT's calculator is an excellent resource. And there's a couple of other resources down the bottom there, Green It Yourself, which has a number of videos on how to upgrade your home to make it more energy efficient, and Mother Earth News. If you're from the 60s, 70s, then Mother Earth was a publication then. It's now online, and it's an amazing resource and tells a pretty good story. And that's about it. So thank you all for attending, and I guess I'll throw it over to you guys for some questions.
Thank you very much, John. And can I just say it's been fascinating listening with one side of my brain, John, as you've presented, and watching with the other as some of the early questions have been coming in. Now, we've actually had a fascinating and quite learned flood of discussion around life cycle analysis of different lighting products, John, which I might get you to talk about in a moment. But where some questions came in quite early, Ian Garrett asked us, John, what's the outlook for improvements in the colour rendering index with LEDs? Because that was quite a problem with CFLs early on.
Most LEDs that you'll get these days, and look for the CRI number on the packet. Most the best that you can get is a percentage. The best that you can get is 100. Most LEDs nowadays are coming out at around about the 80, which is extremely good, and will be fine for all but the most discerning people. Maybe the photographers amongst the audience may not be quite so good with the 80, but it's 80 plus that you'll find with most LEDs these days.
Excellent. Stephen Allen asks, and this is a recent question, can you talk a bit about dimming of LEDs, John?
Okay. Most LEDs up until about a year and a half ago have not been capable of being dimmed. We've just recently, this is an LED downlight replacement this is the first one that we've had in the web shop at the ATA that has been capable of being dimmed. Now, this little beauty will set you back about $40, but it produces a great deal of light. It's about the 440 lumens, which is not quite as much as a 50-watt halogen downlight, but most halogen downlights produce too much light for your needs. The halogen downlight came into being came into vogue more so when we started reducing our ceiling heights down to 8 foot or 2.4 meters. They found that pendant lights didn't work because people kept bumping their heads on, or not their heads, but kept bumping their arms on them when they were sort of putting their arms above their head. So pendant lights weren't such a good idea. The halogen downlights, I actually went to a website once where they had a calculator for the number of halogen downlights that you would need in your home. So I put in my room dimensions into their calculator, and it worked out that I needed 80 downlights in my home. Now that's equivalent, and this is again without the transformer losses, that's equivalent to 4 kilowatts of lighting. Now, how ridiculous is that? 4 kilowatts of lighting. I was recently at a conference. They had 66 downlights in their conference room that held 100 people. That's 3.3 kilowatts of lighting that was on for the whole day. Now, that's crazy. That is really crazy. Energy costs are going up.
Thank you, John.
Yeah.
That's great. Can I take us to another question, if I may? There's a couple of questions I can comment on. Terry Canelos, and I apologise if I pronounce people's names wrong. Terry had a really good question which launched the discussion around life cycle costing. And the first question was around what does this all mean in Tasmania, where the bulk of the electricity comes from hydro. As an old policy wonk myself, I can say obviously the impact immediately is less, Terry, but there are long-term questions about electricity transfers to the mainland, where growth of consumption in Tassie will have an impact on greenhouse gas emissions Australia-wide. So there's always going to be some sort of benefit in reducing both peak demand and long-term energy consumption. There has been quite a lengthy discussion, which I hope everyone's been finding as stimulating as I have, between a number of participants around, John, the question of life cycle costing of not just the energy side, or life cycle analysis, sorry, of not just the energy side of changing forms of light globe, but also the heavy metals implicit in their manufacture, the aluminium heat sinks that are used with LEDs and the like. My apologies to all those who've raised those questions. I won't name you all individually because it's been a very useful piece of conversation. John, do you have any comments on, I think particularly the use of some of the heavy metals and other chemicals in both manufacture, production, and then in the life cycle of some of the LEDs versus CFLs versus incandescents?
Well, CFLs, as everybody's aware, they have mercury in them, which even though I said earlier on that it's not a reason not to use CFLs. LEDs, now that they're becoming more available, LEDs do not have mercury. They are also RoHS compliant, RoHS. It's an international standard, which means that they don't have the lead in the manufacture and other heavy metals. And you'll find that all LEDs are RoHS compliant. So LEDs are a whole lot better. The circuitry inside compact fluorescent lights, that would also be RoHS compliant, but you do have the issues with the mercury, which is a necessary evil in fluorescent lamps. It performs the function of capturing all of the other gases that inside the evacuated envelope of that tube, which allows it to fluoresce the way that it does. So there's no way to get around that mercury that's in that bulb. I've got a calculator which I'm just about to share.
While John's getting that up, there have been a couple of questions about further questions. People asking how they get in touch with John. John, your email is it just John at ATA?
Yeah, John or john.knox.
John or john.knox at ata.org.au is the address to email John with further questions, although we still have another 20 minutes or so to run today.
Yeah. Now this calculator that I've got here, I can change values. Say you're replacing an incandescent bulb that costs $1 that lasts 1,000 hours, with a light emitting diode like the one that we've got in the web shop for 1950. It lasts 36,000 hours, and I'll just do the recalculation. It pays for itself inside a year and a quarter. So in energy savings, it pays for itself inside a year and a quarter, and the expected savings over the lifetime of the bulb. So once you've paid off the bulb, you then get $476 in your pocket over the lifetime of that bulb if you were to use it for 3 hours a night, and the cost of electricity is 25 cents a kilowatt hour. Now the cost of electricity will be going up. Hours of use per night, if you use it less, that will be a slightly longer time. In fact, I can show you at 4 hours. 4 hours a night, it's less than a year. At 2 hours a night, 2 hours a night, it's closer to 2 years. But at the end of that lifetime, you're always going to be saving. Well, you'll be saving more than the 476 because that light, if you were to use it for the 2 hours a night, that light is going to last you very close to 50 years, 49.32 years. Now that's just crazy long. And that's another advantage of your light-emitting diodes. Light-emitting diodes come up to full brightness immediately, and they don't mind being turned on and off. So you can turn them on and off as many times as you like.
John, needless to say, whenever you put a calculator up, you've got the quite reasonable question from a couple of people. Oh, can we get this?
I have no problems. This is something that I put together in my own time, and it's something that I'm more than happy to share. I want people to understand the benefits of LED lighting, and we'll put it up on the site for you to astound your friends with.
A swift download. Thank you very much, John. Now, a couple of questions of a very practical nature, and as always, colleagues, we'll get people with varying degrees of understanding coming into conversations like this, or who've worked more or less on different types of lighting questions. But one question that's come up is just the simple one, because I always have this problem. What's the reality of just simply replacing our current CFLs, which previously replaced our incandescents, with LEDs? What range of light fittings is this a straightforward exercise for? When does it get complicated, John?
As you can see, you can replace the standard bayonet fittings and the Edison screw fittings. They're very readily available these days. We have both bayonet and Edison screw fittings available in our web shop. We've also got the halogen downlight replacement, the 12-volt replacement. GU10s are also available. you're starting to see LEDs coming into their own in floodlight situations as well. So there's going to be massive savings, and in fact, already some councils are starting to roll out LED lighting in the street because the energy savings are so massive. And not only that, the maintenance side of things. If you're only replacing these lamps once every couple of years instead of every 3 or 4 months, then there's massive benefits that councils will receive from rolling out this technology.
There's a couple of questions that have come up, John, about when you'd need a sparky. When do you need to consult with your electrician about anything you're doing with LEDs?
The only time you would need to consult a sparky is if the transformer that's in your ceiling isn't compatible with the bulb. Now, these downlight replacements that we have, these are compatible with most of the transformers on the market. The actual manufacturers of these, and these actually have been designed such that if they start to get too hot, the driver will actually reduce its driving force to the bulb to reduce the amount of heat being generated.
Okay.
It'll actually reduce the amount of light as well, but that comes down gradually. The manufacturer recommends that you put 3 of these on a single at least 3 of these on a single transformer that you've got in your ceiling. Now, with any form of lighting, it's better if you have less numbers of bulbs on the one switch. So if you've got 10 lights on a switch, then it might be an idea to get your sparky in to put in extra switches. That will reduce your lighting requirements. The LEDs, if the transformer is not compatible and the transformer is not plugged into a socket in the ceiling, then you'll need a sparky to do the changeover. If the sparky has put a socket in the ceiling, and that is very commonplace these days, then all you have to do is unplug the previous transformer and plug in a compatible transformer. But again, you can cut down on the transformer losses by having a number of these connected to the one transformer.
Thank you, John. Certainly, colleagues, if you're like me, always better safe than sorry, I'd have to say. There's been an interesting question asked, and I think answered, around a low energy replacement for some of the fluoros. That's in the message box in the bottom right. There's a couple of questions I wanted to answer just administratively. Sunny has asked whether this discussion might be available for people later, the questions that are coming in the message box. I'll leave that with the conference organisers who run the software that does this. If we can capture all of this, then we'll make it, we'll place it all available to be downloaded from the ATA website as well. Jacqueline asked whether there was a replacement for the GU10 halogen.
The GU10 halogen, we don't have the GU10s ourselves, but GU10 halogen replacement LEDs are available. I'd suggest that you go to a reputable lighting shop or a good online supplier of LED lighting. There are quite a number of eco-type shops around, and a Google search will find them very readily. So
the answer is that there should be a replacement,
yeah.
Jacqueline, and I think that should be. There's quite a detailed discussion at the moment between a number of participants, John, which I know you can probably see in the bottom right-hand side as well of the page. One of the questions that's come up from Carolyn Lecouture is around what policy settings we need at the moment to bring in more efficient lighting. Again, I can probably answer some of that, and John, if you want to add anything, please do. I mean, at the moment, of course, with the carbon price working its way through the system, we're seeing quite a lot of interest given to energy use by people. That will have some impact, although it won't solve all the problems we've got. I think at the moment in Victoria and some other states, we have programs which offer small, essentially rebates or certificates for energy efficient products, and those led while incandescents were still legal to quite a lot of replacement of lighting, and those schemes seem to work quite well, like the VEET scheme in Victoria, for those who are familiar with that, also known as the Energy Saver scheme. So there are policy tools governments have got that they can use to specifically target lighting, and of course the ban on incandescents over time will have a huge impact and start to change over a lot of the lighting that's there.
Just on that, Ian, apparently in April of this year, the import of 50-watt quartz halogen downlights is now banned.
Okay. So
as of April this year, it has been banned. You can get the more energy efficient 35-watt halogen downlights, but really, with the amount of time it takes to actually return your investment in the lamps themselves, go for LEDs. It really, really will make a difference. And who wants to climb up that ladder to replace those downlights, which have a tendency to fail on a fairly regular basis? So you'll save yourself trouble of having to climb up and replace them all the time, and you'll be saving the energy on a continuous basis.
So, John, there's a bit of discussion still going on around the R7 halogen tubes. Have you got any comments you can make in terms of availability of replacement products there?
R7. I'm not familiar with that terminology, unfortunately. R7. Is that a light tube, as in a fluorescent tube? I'm not sure what that means.
I'll leave that to Mary or others to come back to us on that one. R7 linear floodlight brackets halogen.
Okay. Oh, yes, I'm with you now. Okay, sorry. Yes, I know what you're talking about now. I'm not aware of linear floodlight replacement tubes like that as yet. I would anticipate that they won't happen, mainly because LEDs require heat sinking. Heat is a source of concern for LEDs, so you want to minimize that as much as possible. The heat sinking will be a part of an actual the floodlight that I was talking about was your screw-in floodlights.
We have thank you, Pete Beard, for commenting. Yes, these do exist. See Google. Terry's also added to that. There's apparently an Irish company met in Frankfurt this year. People can all see these comments, and we will see what we can do to make sure that we've got all these available. I guess this is the point I'd make at this point is that we love this sort of conversation because we actually learn here. No one knows everything in this space, and obviously the amount of people who are investing their time and thinking in the lighting space is fantastic. There's a comment that Donna Luckman, who's the Deputy CEO here at the ATA, placed in the message board there, just reminding people, and I should have mentioned it earlier, you can, of course, continue the discussion after this webinar on lighting at the ATA online forum, www.ata.org.au/forum. There's a very simple registration process to get yourself on there for those who haven't already done so. You don't need to be an ATA member to participate, and I'm sure we can get a conversation going up there. I think we're getting to the point now where some of the conversation we're having might actually be best to continue there. So I think we might draw our webinar now to a close. Thank you very, very much, everyone, for participating today. It's been a great conversation, and thanks very much, John, for your presentation. Obviously, I'd like to thank again the sponsors of this webinar series, bankmecu, Responsible Banking, for their support to the ATA in this. My name's Ian Porter. I'm the Chief Executive at the ATA, and once more, thank you all very, very much for joining us today.
Thank you.